So we're going to explore the essential question of how do we analyze and describe functions using the first derivative. So last class we talked about candidates test and extrema. We're going to dive into some more things that the first derivative tells us. So let's think about a typical increasing function, maybe something like an exponential function, and a typical decreasing exponential function. And I can clearly see that on this exponential increasing function, that everywhere I would go to draw a tangent line, the slopes would be positive. So a function f is said to be increasing on an interval for any two numbers, x1 and x2 on the interval, if f of x1 is smaller than f of x2. So this is just a mathematical definition of increasing, and I can see that if I put x1 here and x2 here, and sure enough, I can see that the y value is smaller at x1. And if we think about a decreasing function, looking at this decreasing function, I can see that everywhere I would go to draw these tangent lines, the slopes of these tangent lines appear to be negative, and we'll use that fact in a minute. So a function f mathematically is described to be decreasing on any interval for two numbers, x1 and x2, if f of x1 is greater than f of x2. And let's look at that on our graph. Let's put x1 here, let's put x2 here, and sure enough, I can see that the y value at x1 is larger. And so moving along into what calculus tells us about increasing and decreasing functions, we know that a positive derivative means the tangent lines are positive, but that actually tells us that f is an increasing function. And if the derivative is negative, then f is a decreasing function. And if the derivative is 0, then f is a constant function. And we can see that in our graphs that we've drawn up here. So let's make some quick sketches. Increasing function, decreasing function, and a constant function. And let's look at these tangent lines. Positive tangent lines, negative tangent lines, and sure enough, a tangent line with a slope of 0. And so where this leads us is to something called the first derivative test. And what the first derivative test says is let C be a critical number. Now we've already learned this concept of critical number. So critical number means my derivative is 0 or my derivative does not exist. And so we're on the open interval I containing some value c, and if f is differentiable on the interval, then f of c can be classified as follows. Important, if f prime changes from positive to negative, then that is a relative maximum. And again, if f prime changes from negative to positive, then that point is a relative minimum. And so let's sketch this out. Our classic example is a parabola. I think that makes kind of the most sense to draw here at this point. And so let's look at both of these. If I look at this point, which is clearly a maximum, everywhere on this side appears to have a derivative that is positive. And everywhere on this side of the maximum appears to have a derivative that is negative. And I can clearly see at this point here, the derivative is 0 because it's a critical number. And so because this derivative is changing sign, this is a relative max. And we look at this point here, which is pretty obviously an absolute and a relative min for that matter. But looking at the left-hand side of the graph here, I can see that all of the derivatives would in fact be negative. And looking at the right-hand side of the graph, all of my derivatives would be positive. And so they're changing signs at that point. And I can clearly see that at this spot of a relative minimum, the derivative is 0, making this a relative min. So when that derivative changes sign, that tells us a lot. And so let's walk through one example together. Find the intervals where f is increasing and decreasing. Identify all points that are relative maximums and minimum points and justify your answers. Now I'm fully aware you could graph this on a graphing calculator and identify your increasing and decreasing intervals, but let's do it with calculus. So step number 1, we need to find our critical numbers by taking our derivative. So our derivative would be x squared minus 2x minus 3. And I want to show that I'm setting that derivative equal to 0. And sure enough, this is a beautiful factorable quadratic into x minus 3 and x plus 1, leading us to two critical numbers, positive 3 and negative 1. Now here's where it is different from candidate's test. We're going to make a number line. Now the AP exam says that your number line is not sufficient work, but you can use it to answer a question. We're going to always label our number line. That is very important. And we're going to put on this number line our negative 1 and our positive 3. Now I already know that the derivative is 0 at these points, but I want to know what's going on in between, in here and in here and in here. So I'm going to pick a number over here, maybe x equals negative 2, maybe x equals 0, and maybe x equals 4. And keep in mind, this is our derivative number line, so we're going to be plugging into the derivative. My preference is the factored form, just because I think it's easier. So we're going to plug in negative 2 minus 3, negative 2 plus 1. Now, I don't really care what the value is. What I do care about is what is the sign of that value. I get a positive. And if I plug in 0 into the factored form, 0 minus 3, 0 plus 1, negative 3 times positive 1 will be negative 3. Every derivative value will be negative in between here. And if I plug in 4, 4 minus 3 and 4 plus 1, I'm going to get 1 times 5 is 5, which is positive. So these are the signs of my derivative because this is a derivative sign chart. But what I can now use is this information up here. Based on the signs of these derivatives, I can tell what f is going to be doing at these points. So above this sign chart, I'm now going to specify what f is doing. If the derivative is positive, then f is increasing. If the derivative is negative, then f is decreasing. And if the derivative is positive, f is increasing. Not only that, but I can also see that this is going to create a relative max right here. And this is going to create a relative min because the derivatives are changing sign. Now this problem asked me to answer multiple things. Number 1, it asked, where is f increasing and f decreasing? So let's answer that based on our sign chart. I can tell that f is increasing from negative infinity to negative 1, and also from 3 to infinity. F is decreasing on the interval from negative 1 to 3. The next thing that it asks me to do is it says to find all points, that means x and y, that are relative maximums and minimums. So I know that there is in fact a relative max at negative 1, but I don't know the y value. We're going to find that y value. So to find that y value, you're going to have to plug into the original function. So let's do that kind of in our brain. Negative 1 cubed is negative 1 times 1/3 will give me negative 1/3. We've got negative 1 squared, which will be plus 1. And then we're going to end up adding 3. So I think that gives us 11/3, and I got that from plugging into the original. Okay, and we know that we're going to have a relative min at 3, but I need that y value. So again, plugging into the original, we've got 3 cubed, which is 27. I'm going to have to multiply by 1/3, which will give me 9. And then I've got 3 squared, which is 9 again. We'll subtract there. And correct me if I'm wrong, I think we end up with negative 7. But there's a piece that we could glaze over if we're not very careful here, and that's that justify your answer. So here's where it's big. We're going to require the following, and the AP exam requires the following. Okay? So we've got our increasing, decreasing. We've got where our relative max and mins are, but here's what we're going to say. Because f prime changes from positive to negative. Now, some important pieces of that. I didn't say it. I said f prime, and I said from positive to negative. And then I have a relative min because f prime changes from negative to positive. If it says justify, the AP exam requires this information. You're never going to use the word it either. So the last piece of this is to make a quick sketch of our functions. So we're going to do that. I've got negative 1, 1, 2, 3. We're going to need to go all the way down to negative 1, 2, 3, 4, 5, 6, 7. And 11/3 will be just shy of 4. And so using the pieces we've got, negative 1 and 11/3, and 3 and negative 7, I know that my function is going to increase up to this point, decrease up to this point, and increase up to this point. And I can see all of the pieces that I found. Increasing, decreasing, and then increasing again. I can also see from this graph that here are the places where the derivative is 0. I can also see from this graph that here are the places that has positive slopes, negative slopes, and positive